Okay, number 14, this is another oblique triangle, so we're either going to use the law of sines or the law of cosines. Well, the law of sines is the one we're going to choose for this one because we have two angles and a side. So if you have two angles and a side, we're going to use law of sines. So the law of sines says that the sine of angle A divided by the side across from A is equal to the sine of B divided by the side across from angle B, and that is also equal to the sine of C divided by the side across from C. So we have angle A and we have angle C, so we're going to use these two expressions. So we're doing sine of A, angle A, which is 65, divided by side across from that angle, which is A, equals the sine of 40 divided by the side across from the angle 40, which is 25. Now we just have a ratio of proportions, so we can solve, cross multiply, and solve here. So we have A times the sine of 40 equals 25 times the sine of 65. Now to get A by itself, we're just going to divide both sides by the sine of 40. So you can now take your calculator and just enter this in. So I'll show you how to do that on the calculator. You're just going to enter 25 times the sine of 65. You want to get that answer first and then divide by the sine of 40. And our answer is 35.25 degrees, nearest tenth, so it's 35.2. So this is 35.2, and it's a length, so that's just units for side length A. Okay. Make sure your calculator is in degree mode as well, so I don't want to check that. Make sure, I should have checked that before. So our mode is in degrees, so we're fine. Okay, so number 15, we have a right triangle ABC, and angle C is the right angle, so I'm going to draw a right triangle with angle C being the right angle. Angle A is 29 degrees, and B, length of B is 8. So I'll put big B over here, and across from big B will be little b, which is 8. So now we need to find all the remaining sides and angles. So let's see. Let's put angle B we can find easily by subtracting from 90, since all three angles in a triangle have to add up to 180. If you take away the 90, the remaining acute angles have to add up to 90. So angle B will be just 90 minus 29. So 90 minus 29 is 61. So this is 61 degrees. So we can put that in there, but I'm not going to, so that I don't confuse you, because I'm going to use 29 for my trig. So for this one, to find side A across from big angle A, and I have my angle 29, this is my adjacent side, and this is my opposite. So using right triangle trig, my adjacent and my opposite is tangent from SOHCAHTOA. SOHCAHTOA. We have opposite and adjacent, so we're going to use tangent. So we'll set up the equation. Tangent of the angle 29 is equal to our opposite side, which we don't know is A, and adjacent is 8. So to get A by itself, we just multiply out the 8. So A is equal to 8 times the tangent of 29. And we can do that in our calculator. 8 times the tangent of 29, and that's 4.4. So side A is 4.4. Okay, and then C, to find side C. Now that we have two sides, you could use the Pythagorean theorem, but trig for me is easier and quicker, so I'm just going to use trig. Side C is right here. That's our hypotenuse. So we're going to use the adjacent and the hypotenuse. Adjacent and hypotenuse is the cosine. So we'll set up cosine of the angle, which is 29, is equal to the adjacent over the hypotenuse. So cosine of 29 is equal to 8 over c. Now our variables in the denominator, so properties of proportions allows us to switch diagonally. So we'll switch the c out and replace it with the cosine of 29. So c is just going to equal 8 divided by the cosine of 29. So we can do that again in the calculator. 8 divided by cosine of 29, and that will give us 9.14. And we need the nearest tenth, so we'll just do 9.1.